So for our quantitative results, we'll be first demoing the CARLA simulator on 5 different maps, and then we're going to be giving a quick analysis of each map. Okay, so our car was able to stop at the red and go at the green. Turning right led it into a trash can, so let's try this again. Making the same turn resulted in similar results, but the steering model did clutch up and it was able to make the left turn. Our traffic light classifier, with high confidence, was able to detect the traffic light states. Our steering angle classifiers seem to predict high levels of abnormalities, and this is probably due to the right turns in this map being much wider than any other map. Okay, so we did stop at the red, and then we went at the green, made a right turn, and crashed into some sort of sign. And here we go, and it seems like map number 2. Super messed up. We're sitting at a red light, making a left turn, successfully done so, and now we're on the road, staying at this red light. Traffic classifier seems like it's working quite nicely. And over here, we get onto a road, which is unfamiliar and never trained for, and it seems to catch on. Map 2 is just a mess. Traffic lights work, but steering not so much. I believe it's because there are buildings that are as gray as a road, and thus, instead of making a turn, the steering classifier wishes to proceed forward. Map 3, however, is the complete opposite. Traffic lights work, velocity seems to be at a nice speed for residential roads, and even unconventional and untrained roads seem to be handled perfectly. Okay, so for this map, we can see that most of the map is highway, and thus our velocity model does want to go at high speeds. However, once we reach the little town with the gas station, there seems to be a problem while trying to turn left, which eventually led us off the road into the mountains. Map 4 itself is a highway, and thus when we went to the gas station and the velocity model should have slowed down but didn't, we can see that there was a high probability of overfitting due to the map's environment. And thus we can see that the velocity model is actually dependent on the map itself. It overfit and actually recognized that, hey, this is the map that we're driving on. Okay, so this Coke sign is making our traffic light model predict red. However, the confidence is so low that the car isn't going to stop for the Coke sign. Seems like there's a little bit of a sidewalk mishap here. It does find the road again, but directly after skips a red light. This was the first time this happened, and drives clear for the rest of the ride. For map number 5, we can see that steering is almost there. Car velocity is handled great. Traffic lights seem to have a problem. Unlike the other maps, there is quite a bit of greenery in the back behind the traffic lights, which seemingly make the model think that the red light was a green light. Similarly, the Coke sign indicating a red light, which is handled a lot better and mitigated due to low confidence. Now that we demoed our model and discovered its issues, let's see how the numbers add up. For the steering results, the model achieved a 53% accuracy and an entropy loss of 1.79. From the demo, we can see that this number is not so far off in particular areas of the maps. However, some of the accuracy was lost because there was 15 classes that it was classifying from, and that led to poor performance. For the velocity results, we see that there is a mean absolute error of 0.96 meters per second and an R-squared score of 0.85. That means 85% of our predictions matched the true speed. But we saw that our velocity model does pick up on location, so particular maps get overfit and the general speed of the map is picked up. For the traffic light results, we see that there is a 99.8% accuracy. If this accuracy is so high, how do we let our car pass that last traffic light? Well, that is because the accuracy is based off the prediction and not the confidence. We handle confidence separately in a module which all 3 models go into before the car ever moves.